Welcome.
To the joy of coding.
Hello, and welcome to episode 331 of The Joy of Coding. My name is Mike Conley. It's so good to have you here. If this is your first time, welcome to the stream. If you're returning, if this isn't your first time, welcome back. If you're watching this from the future, from one of the recordings, I hope things are going well. And if you're watching this from the past, how are you doing that? So good to have you here. Going to be live hacking on some Firefox stuff today. Without further ado, let me share my screen and we can get ourselves started. It is episode 331, July 5th, 2023. A reminder, no plan survives breakfast. I think I know what I want to do today. I think I know how I want to proceed with things, but it might not go according to plan. I might get blocked, sidelined, rat-holed, whatever you want to call it. None of the code that I'm going to be writing, for example, is anything I've pre-written. I haven't got, like, the solutions on a piece of paper next to me that I'm just going to rattle out. So I might, who knows what'll happen. We're going to capture software development in the raw. That's how we work here. That's the first thing. The second thing is, the agenda that we're looking at is something that you have access to. If you're watching this on AirMozilla, check out the details section on that side of the video. If you're watching this on YouTube or diode.zone, check out the video description. And if you're watching this on Twitch, there's also a link down in the channel details to the agenda. And as I update the agenda and this little spinny spins, it should update if you reload the page. Okay, that's the preamble. Let's jump right into it. The first thing I wanted to talk to you about today is about a place that I'm starting to get used to, which is you may be familiar with a site called Reddit. Reddit used to have what's called a subreddit it was just the Firefox subreddit. And that subreddit is now dedicated entirely, as I understand it, to pictures of red pandas, which is great. And the one of the moderators has started up a community on a site called Fedia.io, which is using a piece of software called Kbin. It's similar to Reddit in that you upvote and downvote things. You can submit links. There's a similar one called Lemmy. They both use ActivityPub so that they can kind of communicate with one another. They're both federated. And Fedia.io is a Kbin instance, and there's a Firefox community that one of the moderators from the original Reddit Firefox subreddit has started. And that's where I've been posting links for this stream, for example. So some of the people watching the stream might be from, the Threadiverse is what I've heard one of the terms being bandied about is. And if you are, well, welcome. It's good to see you. And if you're not familiar with this, maybe check it out. Check it out. There's we're trying to, I think, build a community, salvage our Firefox community. That subreddit. I think there were a lot of users there helping each other out and giving each other tips and sharing news and, helping to sometimes there was even like support stuff like you would normally find on support.mozilla.org sometimes happened on the old Firefox subreddit. So I think there's an effort now to try and rebuild some of that community in a couple of different places, and this is one of them. All right, so that's the first thing. Let's get into Windows jump lists. So if you're new to the stream, I'll quickly recap. Over the past, 8-10 streams, let's look at the 321. What was I doing? Was I doing jump list stuff back then? Not really. Well, a little bit. Yeah, okay. We've been working on jump list stuff. Holy smokes, when did I start doing jump list stuff? Pin to toolbar. Back to Windows jump list. I think I've been working on this maybe almost a year. Is that true? That'd be crazy. Let's coalesce items in the tray, hang stats. Yeah, I think I started this in August. So we're coming up to a year. Now that's the thing. I've only been working on this during the stream. I haven't been working on it off of the stream, and I got sidetracked in a bunch of other stuff. But since episode, it seems 297, we've been working on this, and we're actually at a pretty good spot now. We built it up. We tore it down. We rebuilt it. Maybe I'll start over because I need to sort of explain what's going on for the people who are new. Jump lists. If you're not familiar with jump lists, on Windows you have these items that will appear when you like right click on an item. On Windows 7 is when I think it was introduced, and this is called the Windows jump list. And the Windows jump list actually exists outside of the lifetime of the application. So, for example, right-clicking on if I closed Sublime, or if I closed Firefox, my instance of Nightly here, and right-clicked on it, it would still have items listed in it. And that's because you write the list of items, and you have some control over what items appear and what subheaders they have, etc. You write them to the Windows file system somewhere. You go through a specific Win32 API to do it, but you write it, and then when you shut down, it persists so that the users can like launch stuff from the icon in the taskbar if it happens to be there, if the application happens to be there. And the way that Firefox has typically done this is we have a component in the front end that will periodically update the taskbar, the jump list with relevant history items, and that writing mostly happens off of the main thread, but some of it happens on the main thread, and that can result in hangs. Where this is an action whenever you're persisting things to disk, where especially for users that have old school SSD spinning Rust hard drives, depending on what the machine is doing, can be a costly process. And if you are doing that on the main thread, or you are blocked on that on the main thread, the responsiveness of your application can suffer. I have a blog post about this, actually. I have a blog post about disk access that might interest some people, where I talk a little bit about, it's an older blog post, but it might still be relevant. A few words, more than a few words, on main thread disk access for general audiences. So in case you're curious about that, check that blog post out, where I talk about what the deal is, what's so wrong with accessing the disk on the main thread, and what do we need to worry about, etc. Anyways, so over time, we've been rebuilding the jump list mechanism to run entirely off of the main thread, so that the main thread, the part that the user interacts with and responds to user input events, stays responsive, or at least doesn't get its responsiveness blocked by disk access. And we've made great progress. Last week, we got it actually hooked up to the front end, and it was working. Now, we were using optimized builds. We were not using debug builds. I have now prepared our patches. I've rebased them onto a more recent Mozilla Central. If we take a look, whoop, not GOG, sorry, HGGlog. If we take a look at my push here, it's from June 28th, so it's only a week old. I pulled from Central last week and rebased, and I haven't touched this machine since. But this is a debug build. I want to actually see what happens when we run this with debug on, because that will catch a lot more more of our assertions become fatal, when we're on debug builds, and I want to make sure that we don't hit any of those. So let's start by launching this and turning on our new backend. If I recall, there's a pref that we introduced that we have to flip on. All right, now just FYI, our debug builds are not optimized, so they are necessarily slower. So it might take a second here before things start showing up. See, like it's quite a bit more sluggish. That's expected for a debug build, an unoptimized debug build. Build time optimizations. They are important things, as you can probably tell. All right, so we're going to turn off the legacy backend, and we are going to restart using the new backend. Wait until all of this stuff finishes shutting down. A lot of warnings, but not really relevant to what we were doing. Okay, here we go. Now, as I recall, there is a way we can sort of sidestep waiting for the timer. Right now, we're having to wait for the timer because, you know, that's the way this whole thing works, is it uses a timer to update the jump list. But we can sidestep that by loading the Windows jump list module. If I can get the resource URL for it. And I think it's the object that we want is Win taskbar jump list. Taskbar jump list equal Chrome utils import ES module. Oops. Okay, so that should get us what we want, and then I'm going to call update on it. And this, if all goes well, should not crash. Okay, we didn't crash. And we get things showing up in here. So if I were to, for example, visit this GQ page about, I presume, Tim Robinson, and then rerun that command, doesn't crash. We right click. Here we go. Yeah, it shows up. Now, one thing I've noticed right away is that there's no the fav icon. The fav icon isn't present. So that is something that's broken. We're going to want to look into that. Why aren't the fav icons working? We've done this part where we've gotten the jump list builder to choose the right jump list module to use the right builder based on the pref. I would like to know why the fav icons aren't showing up. Maybe there's a delay, because I see that there's a fav icon here for AMO. Let's try it again. Yeah, okay, so I think that is a known issue where, like, the first time, like, I think it's always been this way. The first time that you visit the site, the fav icon won't exist on disk. It has to be written to disk and not just be in our favicon database. And we don't do that unless the favicon is in our database already, and that might not be the case whenever we run update. So long story short, that was a pre-existing issue, but we have it. We have the fav icons showing up. That all works. And then if I right click on this and choose remove this from the list, it should also remove the page from my history, if I remember correctly. So right click, and if I choose like update again, ooh, that's interesting. Error unexpected. I wonder where that came from. We'll have to look at that. Error failure now. Okay, so we've got an interesting bug here where after doing a removal, why aren't fav icons working? We can answer that now. It was always this way. There's a moment in time right after the page visits where the fav icon hasn't yet been written to disk, but after it has been, the fav icon becomes present, usually the update immediately after. Okay. After doing a removal, I saw a NS error unexpected and then an NS error failure for each subsequent update. Why is that? I suspect that the error failure is because the item is still in our history, and when you've removed an item from history, it's not supposed to when you've removed it from the jump list, you shouldn't attempt to re-add it. And so this is Windows complaining to us of like, hey, you were supposed to remove that. Yeah, it's still here in our history. So we failed to remove it from history, and so each subsequent update is attempting to put it back, and that I think is causing our issue with the error failure. So if I run update again, I suspect we will not see the error failure. Oh, I'm wrong. Well, now I'm very curious. Um, let's see what our console is saying. Is it error failure in WinUtils? So there were a couple of failures. We saw. Jumpless Builder 210 seems to be one of the places. And WinUtils 868. Let's see what's going on there. Jumpless Builder 210. We are failing because obtain cached icon file is failing. What were we doing before? Cached icon file. And where is it failing in? Obtain cached icon file is failing at. It claims 868. When decoding an image, some data. Not able to decode an image. Interesting. Okay. Well, I don't think this is supposed to be fatal. Obtain and cache favicon. Who's calling obtain and cache favicon? Probably our front end. Here. Oh, right. And then it looks like we're intentionally just sort of like throwing away the exception. That was, this requires some commentary. Whoopsie daisy. Oh, hold on a second. I'm in the wrong file. Windows jumplist.jsm. I need to be in Windows jumplist.sys.mjs because we rebased. Okay. To do document why we're catching exceptions silently here and maybe be a bit more choosy about which exceptions we eat silently. So I think what we've determined. Oh, and then there's this, yeah, 210 error not available. Was that the one we were already looking at? Jumpless Builder 210 error not available. Well, that's interesting. Obtain cached icon file is returning error not available. Multiple times. I think that's expected now that I think about it, because there are a number of these, like, count how many there are. 1, 2, 3, 4, 5, and there are 1, 2, 3, 4, 5 of these that we're falling back to the. I think it's basically the saying, we don't have any favicons, and that's expected, and I think that's okay. So I think these are expected, and I also think that they are a red herring. This I'm more interested in. Where is this NS error failure coming from? And like maybe that's from this. Like I think these are a red herring. These might be more interesting, and I don't know what they're from. There is some relationship there. Now the good news is we have a debug build, which means we can attach Visual Studio to it, and we can actually debug the parent process is 19732. WinUtils 868. So I'm going to set a breakpoint. What's it called? 868 was called async favicon data ready on complete. This is the whole, that's the whole name. Mozilla widget async favicon data ready on complete condition. No, I don't have a condition. We're just going to add that breakpoint. Now we're going to hit a couple of these as we've seen here, and the first 5 I think are expected, but really this is just to get me to this file. Let's hit our breakpoint. So we're running here. Where's foreground it? Come on, come on. It's all quite a bit slow. Oh, did I hit it already? Continue. Maybe I hit the timer naturally, in which case what I want is line 868. I want here. Okay. And RV. I want to know what RV is. How do I just write, can I just examine NS error failure? That's the one we wanted. We got it from decode from buffer. And what is the URL that we were trying to get it from? So we're looking, what's the favicon URI? I think we can do a bit better than that. What's the right place to, I need to cast this. Type. been a while since I've done this. Is it? Will it let me do that? No. How do I cast? You don't know how to cast this? I need to know what the URL is. I can see what path it's trying to load. Jumpless cache, and then there's this thing. 7DT, BP, etc., etc., etc. And what was in the buffer? Decode from buffer. Data. There is some kind of SVG here. So there is something there, but we are failing to decode it properly. The question is, do I have that file on the disk? I mean, probably. There's, let's copy the value and we'll find out. But I'm pretty sure I do, because there's some data that we're attempting to decode here. Hello? I'd like to minimize everything, please. I can't minimize everything because I'm stuck. All right, fine. So the same idea for each. Data. Yeah, there's an image there too. A couple of images. Okay, I'm gonna disable this breakpoint for now. We're just gonna continue. Let's see what's at that directory. Let's open up Finder. Hold on, a lot of escaped slashes here. That's the one we're looking for, 7DT. So it isn't, there isn't something there. That's interesting. I don't even know. All right, where'd this data come from, though? A data comes from icon file, get the path, get output icon path from the favicon helper. Maybe that's what we would eventually write to. Fill rect, draw surface, and then allocate a new buffer. Write icon. That's why. There's nothing there. We haven't, because we fail. What we're trying to do is read in something from the, presumably the database, the favicon database, and then write it to the disk. And then we're failing to do that. But this shouldn't be fatal. That's the thing. This shouldn't be fatal. And I'm curious to know where in our JavaScript this error failure is occurring. So what I'm going to do is I'm actually going to close. I'm going to keep this open, but I'm going to open up the debugger. And I'd like to know – 'cause, 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 'c man. Yeah, this is where debug builds really don't shine, is in their responsiveness. Would you want to do debugging? Come on. Debugger, there you are. It's just taking a little while. We just need the parent process. Thank you. Okay. And was this something that was always kind of broken? That's the other thing. It's like, I want to fix the main thread issue, but I don't want to fix the world necessarily. Oh, do I have to reopen this? Where are the rest of the sources? I think I opened this in the wrong context. This has happened before, where you have to like be, yeah, here I'll be on this web page, and then I have to open up the browser toolbox in just the right context. I think that's an existing bug. I've seen it in other places. If you're using the browser toolbox, chances are you're not a typical user of Firefox, which means the bugs don't get super prioritized. And so we just learn to live with some of the bugs in the browser toolbox. Well, here's another question. Now that I've browsed to this other website and I've got more history, is this a fatal error? Like if I were to run update again, does it prevent this page from showing up in the jump list? Oh, now I don't get an error at all. Although it doesn't show up in here. This is fascinating. Let's go to another site. Let's go to fedia.io/c/Firefox, or m/Firefox. M is for magazine, apparently, because that's the Fedia term. Let's add that to our history. Okay, great. Now that that's in the history, let's run this. Things seem to be kind of broken here. Now, what happens if I restart? So I don't think we are bug free here. I think we've got, ooh, this is also very important. We hit a crash on shutdown. That's something I really wanted to know about. Hit Moz crash. Jumpless backend is not thread safe. On assert current threads own me on native jumpless backend release. So the background thread ran shutdown backend. Do shutdown backend on line 195. Here. We set it to null. And jumpless backend release, assert ownership, assert current thread owns me, hit Moz crash. Auto owning thread. That's interesting, because me in this case Do shutdown backend. We presume we are not the main thread. Jump list backend, not main thread. Not thread safe. On native jump list backend release. That's jump list builder 39. I have a feeling that's one of our macros that we're getting. Yeah. Current thread owns me. And what thread is this warning? I'm in my breakpoint here. What is my current thread? Jump list 15. I'm on the jump list thread. Stack. This is a thread. This being a thread. So our smart pointer, we are releasing on exit, we get rid of here's the thread. We clear the pointer. It's not the actual clearing of the pointer that we're crashing on. It's on exiting the do shutdown backend, which is really interesting. Line 195. And who calls do shutdown backend? This task runner. It's all kind of, I think, confused here by some of our lambdas, but do shut down backend. We dispatch that. And then we tell the thread to shut down. Clear the jump list backend. The jump list backend does ref counting, and that's what's causing the crash, is that the current thread doesn't own me. Who is the current thread? Is current thread. PR current thread. Who is PR current thread? How do I get? How do I run like? Oh, this is more like it. I think int. If you are calling qualify name. Type name is not allowed. Int. How do I find out what the thread currently M thread 1976 CD 5FOO. And that, oh, that's what our current thread is 7FFE. How do I examine? I want to examine you. Okay. So for some reason, the current thread isn't the owning thread of this. The native jump list backend, recall the reference to the native jump list backend. M jump list backend. The pointer to it is here. If this is going down first, that might be the problem, is that the jump list builder is getting destroyed and it's not the one that owned it. It's not the one that constructed it. What do we want to do in that case? This is the more interesting problem. We were dealing with that, like, whoa, what's with that NS error failure? What's with the... But this is the more interesting problem, and the one that I was worried about, but the one I'm glad we're hitting, which is, you know, shutting down this multi-threaded constellation that we have here. How to make sure that we shut it down in the right order. Well, let's look at some other examples. My favorite example is hang monitor child, I think is what it's called. Process hang monitor. I think hang monitor child has some stuff that is owned. It's a Boolean that's on the main thread. Done. It's a lot of guarding and monitoring. Do I, for example, on the destructor, do I have to like block release assert is on main thread, Moz assert? Okay. How do I like on shutdown? That's when we like take a lock and we wait. What's another place where we might do this sort of thing? Background threads. It's maybe storage. That's another place we might look, like Moz storage. Moz storage service. So whenever it's destroyed, like a profile after change or observed, does it have the observer? We're shutting down threads. I feel that I was behooves us to hold strong arms to ourselves so our calls to get connections now happen oddly. Services kept alive by our strong observer references and references held by connection instances. Oh, is that what's going on here? Because, like, notice that the crash occurred. Check this out. The crash occurred on exit of do shutdown backend. I think what's happened is that that was the last thing keeping the jump list builder alive. And what we really need to do, I think, is keep a Kung Fu Death Grip. Oh, spin, event loop until. Oh, I don't want to do that. Is that really what we have to do? Is wait until all the threads close? Okay, well, what I want to do right now, before we get too bogged down with hypotheses, is see how easy it is to reproduce this. I suspect that this is going to be easy to reproduce. That this is the sort of thing that just by shutting down, we're going to hit. That's my hypothesis. Okay, let's see. Oh, I'm wrong. Okay, so maybe we have to import, we have to do that console thing and have at least imported it or run it once. And then let's see if we crash. I'm loving this Tim Robinson in my face every time I load up the browser. That's great. Look at this face. So good. All right. We load it. We update. There we go. And now we're going to shut down. No? So maybe we have non-deterministic behavior here. Non-deterministic shutdown behavior? That's less good. Let's try it again. Or is it because I ran to those NS errors? Yeah, that's the next step, I think, is like seeing if we can reproduce those NS errors and then shut down and see if that's sort of the common factor here. Okay, so we're going to do it one more time. Update. There's some stuff. Let's shut down the browser. Okay. Let's try your idea, SmurfD. Let's see if we can recreate those errors and see if that is the common factor. I like that idea. That'd be interesting if these two things are related to one another. Okay, now let's get rid of Fedia. Okay. Error unexpected. Error failure. Okay. And now we shut down. Huh. Debugging like Tim Robinson. I don't even know what I'm doing here. I don't think you can do that. Yeah. I realized that GQ article, which I read earlier today actually, is about how people, particularly I think straight white males, seem to take on the Tim Robinson persona. I am guilty of that, I'd say. I really enjoy I Think You Should Leave on Netflix. I don't know why I enjoy it so much. It's just eminently quotable. Well, we are in an interesting position. The interesting shutdown crash is gone. But we did see that error, the removal error, and I'd like to... Oh, and now it's back. Now the site is back that I tried to remove. I think we need to understand what's going on here. That removal thing definitely needs to work. So let's open up our browser toolbox and see if we can figure out what's going wrong here. Or thinking of his facial expressions. That's my best Tim Robinson facial expression. Okay, I'm going to set a breakpoint in Windows Jump List, the part where we actually remove things from history, which is here, clear history on the removed URLs. I want to see that part. Windows Jump Lists. No, not gonna do it. Oh, debug builds. You're killing me. It's a debug build on a machine that I'm more or less remoting into, like with not exactly VNC, but almost. So everything's quite sluggish. Windows Jump Lists, and the debugger is also in a debug build, so like everything is like layers of slow. Okay, clear history. I'm gonna set a breakpoint here. Come on. Come on. I'm gonna set. I want breakpoints on 244 and 243. Let's go. Thank you. Please don't remove those breakpoints. Okay, here we go. I guess I have to type that thing in the console again. It's helpful if it's in the toolbox console as well. So I'm going to actually copy and paste it from here, because I don't think they share the same back forward history. No? You're going to get all locked up? All right. All right, be that way. I can work with that. Now, I didn't actually do any removals. So maybe that did nothing. Okay. Carpenter bees. Remove. Am I at a breakpoint? What's going on here? Why is everything so unresponsive? Like more so than normal. This is intolerable, as Indiana Jones's dad would say. Hmm. All right. Well, if this isn't going to be fruitful, then we might have to use either printf debugging. The whole browser appears to have locked up, almost as if I'm at a breakpoint, but it's not showing me at that breakpoint. I suspect I'm in the breakpoint, and if I were to close the debugger, things would, yeah, become responsive again. I think the debugger was just like broken. So here's what I'm going to do. I'm going to shut down, and I'm going to, and here we go. Not thread safe. There's our crash. I think what's happening, here's what I think is happening with that crash, and I can't prove it because I can't reproduce it reliably, but I have a feeling that the jump list builder the last thing keeping the reference to the jump list builder alive is the lambda. Except I release jump list backend release the native jump list backend. See, the native jump list backend should have gone away because it should have been cleared here. Clearing jump list backend. Done clearing jump list backend. And then up here in the destructor, native jump list backend destroying. Unless there's something else keeping it alive. Okay, well, let's build that, but also let us do the other thing, which was over here. I want to console.log removed URLs. And then clear history. console.log removing URLs via places, your eyes to remove, else console.log no removals necessary, apparently, which is strange. Console.log evaluating spec. All right, let's build all this. Now you were in a bad state with the hang, maybe similar to when I hit those NS errors. Yeah, I mean, but I thought we had hit those NS errors before and shut down. So I do think there is a relationship. At least the evidence suggests there's a relationship, but it doesn't appear to be very reliable. I might have to watch the footage later to see if there's a step that I'm doing that I'm missing. This is very frustrating. Maybe I had to remove a different site. All right. I'm very curious to know how other things like this one. So this is one possibility: is you block the main thread and spin the event loop until the threads are done shutting down, and keep yourself alive until then. Not amazing. But possible. What are other things that use threads that would need to shut down? Our media stack. DOM workers. Is there like a worker service? Remote workers. Chrome worker. Worker thread. NSI. What is a thread observer? NSI thread observer. What is that? Near with HTML on a layered event queue. That's not what I want. One thread to solve the right, another threads read the value, but code the right. They're also out of band variance. No threads. Doesn't tell stack lines or when the mutex is on to freed. Follow locking maybe by mutex assert current thread owns. That's not exactly what I need to do. Thread safety. Oh wow, look at these people. Dan Mosdale, what do you have to say? Proxies. Yeah, this is all way at it. This is 2004. There's none of that's going to be useful. All right. Well, if you set those two breaker points, read those steps to see if you hit, and wait a bit before shutdown, Maybe that would help sort of tip the scales during the race. Is that what you mean, Smurfy? To help make it more reproducible. Oh, nothing got removed. That's interesting, because that shouldn't be true. We did remove something. Oh. Remove. Ah, uh-huh. That's a problem. And now do I crash? Looks like no. Looks like no. Okay. So the Jumpless Builder backend is not giving us back the removed URLs. That's one of the problems here. Populate Jumpless should resolve with the do populate. It's supposed to resolve with the list of the removed URLs, and it's not doing that. URIs to remove. And where do those come from? URIs to remove. Here. Remove icon cache and Jumpless shortcut URIs. Okay, well, at least here's what we're going to do. We're going to run, and then we're going to attach a breakpoint again. This is something that we can step through in our debugger. Again, not the biggest fan of Visual Studio. It's okay. I kind of wish I had GDB or LLDB. Do populate jump list. We're gonna URIs to remove. I want to set a breakpoint here. Okay. Let's start by just doing a normal update. It's probably not happy by the fact that I've still got some of those entries in my history. So let's start from scratch. Let's create some history. How come I'm not hitting this breakpoint? Oh, I need to attach. I need to attach to the thread, which is 25232 is the process. And then we are going to remove that breakpoint. Don't need that anymore. And we're going to say right click. We're going to remove this one. And let's go with update. Here we go. So URIs to remove is empty. So we're going to, that's fine because we have to step in. We're going to populate it in this revert. Okay. Step in, step in, step in. Okay. Not on the main thread. Count. 0. Object array. There's nothing in here? Object array. Begin list returned 0. That's very unusual. Something wrong with our pass-through? Step in. What? I expected us to enter this up here. Here we go. Okay. And what is HR? HR is failing. HR is failing. I think we're in a really bad state. I think we need to shut down and begin again. Like that. We're in a bad state. I think we need to shut down. I seem to recall that from the last time I dug into this, is that like you can easily, this is very stateful. Oh, and then here's our crash. Clearing M jump list backend. Then we hit the crash. Clearing. We didn't complete doing it. I see. We don't complete doing it. Or when we do the release, operator 198. don't get it. I don't get it. But there is a console error here. Like something else was keeping it alive. Okay. Very curious. Curiouser and curiouser. Curiouser and curiouser. The thread. We're not on the main thread. I can tell that from here. We're on some other thread. What thread? You know, attaching the I should have kept the debugger attached, and then we could have maybe taken a closer look. Maybe we can do some more smarter things to see which threads we're on. Okay, so let's threads we're on and what threads exist, and let's just create some history. Okay. Oh, still failure. Can we attach our debugger now? 1940. Was it 19488? I apologize. This is a quagmire. I wish that we were getting some more definitive answers of what's going wrong here. Okay, shut her down. That's interesting. I had a breakpoint here to begin the list on shutdown. Begin list. That's interesting. Like, it's almost like I don't know if you saw that. We were asked to populate the jump list on shutdown. Change. Shutdown. What do we do on shutdown? Update shutdown state. That's something that the jump list, we just say we are shutting down. That's something I'm going to want to look at too. And then notice, and then we crashed. So what I wanted to know, now that we're here, we are on thread. These are all of our threads. The main thread is 24764. The jump list thread We have several jump list threads. We've got one here, and we've got one here. Where does that come from? That's this. This is the IO thread. We create 2 of these things? Is that possible? Yes, one for the private browsing builder. Okay, that makes sense. That makes sense. We want one for each. I think that's how it used to work as well for the other back end. Jump list builder. Yeah, each one has one of these lazy idle threads. So that makes sense. But we are claiming that destroying the native jump list backend here, having done that, beginning the cleanup, window. I'm on thread 15404. What is the object? Owning thread. That's this. 2E86804. The owning thread of jump list builder is 2E86. And my IO thread is 2E87. Pointer. Okay. And then 2E86 is the owning thread of the jump list builder. The jump list builder is constructed on the main thread. So I believe no, we would have crashed. Jump list builder was constructed on the main thread. However, several of its methods and resources are called and accessed off of the main thread. We have told the thread that does that work to shut down. The jump list backend, that's interesting. The jump list backend is now null. And if we look at the call stack for jump list backend, our owning thread is 2E87, different owning thread. Right. The owning thread of the native jump list backend is different from the owning thread of jump list builder. Right. That makes sense. So then we clear it. And what thread are we on right now? Like, what is the current thread? Yeah, IO thread is 2E87. IO thread is the owning thread of the jump list backend. What thread are we on? Current thread. PR current thread. Get current thread. PR get current thread. I just want the ID. Can I just do this? How about this? How about this? Visual Studio immediate window. Print call result. Right? That's what I want. I want the... I'm in the immediate window. I don't even know what the immediate window is. Visual Studio immediate window. What is that? Do you debug and evaluate expressions to display the values of variables? You can use the print command. Debug.print, the question mark, mref count. Okay. Can I call methods? PR get current thread. Well, that's returning void would be meaningless. I want the thread ID. Thread ID. Thread ID. I want the thread ID. Where's the thread ID? The native thread ID. Get TID. Can I just use that? That's Linuxy. How do I do it on Windows? Current thread ID. Is that just something I have access to? What's the... D word? Does it want this? How to call method from immediate window. Do I have to put in parentheses? Casting. Get some. need to... No type information. Immediate window. So just have to type information yourself. Wow. Okay. D word type 32-bit unsigned integer. Uint 32. So uint 32t. I don't think this is gonna work. Oh, wait. I see. I think I have to also say what cast to type in 32t. Well, let's just see what happens if I use the same structure. No, that's not right. It was like 2 parentheses and then void, and then 2 parentheses, and then the name, expected an expression. Have you looked at this one? Yeah. I think I need a... The problem is that I doesn't know anything about the function I'm trying to call. It doesn't know what get current thread ID. So I'm on thread 15404. Maybe I don't need to get the current thread ID. Maybe I'm wasting time. We know what the ID of the current thread is. The ID of the current thread, if I go up the call stack, like we know the address, because the current thread is, it's got to be the IO thread, 2E87. And we're hitting crash because assert current thread owns me. If we're not, is current thread, and is current thread is M thread 2E87, and the result of P R current thread. What is the result of PR get current thread? I'm on thread 15404. That's got to be the IO thread. So what thread am I on? If I'm releasing... Well, what I can do... What I can do... PR current thread. That's the one, right? PR current thread. Get current thread. I just need to like hold on to a thread. What is an M thread? It's a void star. PR thread star. Thread equals PR get current thread. All right, let's see if that builds. And then we can maybe compare and contrast. We are over time, but I am desperate to figure out what's going on here. I'd like to get us some answers. I also want to know why we weren't getting back any items during removal. I'm very confused. This is a conundrum. A fascinating conundrum that I think is worth going into overtime for. I apologize that this is... Oh, unused variable. Oh, okay, that's fine. I imagine you wanted, if especially if this is your first time watching the stream, that you wanted more dazzling lights. But this kind of puzzle is kind of what, especially if you're doing native level C++ multi-threading, is the sort of thing that you will periodically run into. What thread am I executing on? What is this spaghetti? We were dealing with this before in the old backend as well. So we have no one to blame but ourselves, because we are the ones who designed this backend. But I think we're going to figure it out. It's just a matter of figuring it out. Yeah. And there are a couple of things I want to do. Like this, these are mysteries stacked on top of other mysteries. 288-804. 288-804. Too many eights. I want to put this breakpoint back. Why is it warning me? Source code is different from the original version. Can I reload the file? How do I reload the file? Okay, well, let's close the file. Why are you complaining? It's saying must match source. Allow the source code to be different from... I don't need it. I need... Well, for goodness sake. Stop. I don't know what your problem is, but we're going to start. We need to get our relationship under control here, Visual Studio. 28804. New breakpoint. And the breakpoint will be at do populate jump list. Jump list builder. I think it'll be like Mozilla widget jump list builder do populate jump list. It's a legit symbol. Okay, here we go. Okay, here we go. We do have a jump list backend. There shouldn't be any items to remove. Begin list. URIs to remove. Should still be empty. Yep. Continue. Unexpected again. Why did we unexpected? What part of unexpected occurred? Create an instance. Go through the task descriptions. We add the things. We add the user tasks. We say commit. Release the error handler. And then we populate the jump list. So that works. It's the subsequent one for the private browsing one. I see. Right, because we create two of them. Is that the issue? We've got two jump lists. Jump list and jump list builders. Two backends. Two threads, separate threads. The user tasks. Adding the user tasks fails. Why would that fail? What is the... I think we added this last week, the app model ID. Seriously? This... private browsing window. Got it. Is that the one that fails? No, it's not the one that fails. And here we are the non-private browsing window ID. Is this the one that fails? Yes. What are the user tasks again? The user tasks are like it's having a problem adding the user tasks. Jump list. Task descriptions. No custom descriptions. No custom title. There are some task descriptions. Open a new browser tab. Open a new browser window. Open a new window in private browsing mode. Okay. And we are in the private browsing one. This is fine. We can create these things and then we add them. HR is 0, no problem. Now, here we are with a different set of, we've got custom descriptions and custom title. Okay, so here we are with our our URLs and stuff. And I presume some of these URLs are ones that we've removed in the past, like is the yeah, fedia.io, which shouldn't be there but is there because I mean these things weren't removed before. So that part is broken, and I wonder if that's the root of what's going wrong here. We say, okay, we have our back end, but we're just going to start with beginning a list. Begin list. What is a? This fails. That's why. It fails. We can't even begin the list. So that's one thing we need to do. We need to put a check here. Just beginning the list fails. And if I remember correctly, there's something about that in here. After a call to commit list is made with no failed call to append category. I think we are in a situation where commit list failed. As long as no call to append category in the session failed for attempting to include a removed item. Calling commit list causes the stored list of removed items to be cleared and a new list of removed items to begin. So I think this is important. That's kind of the mystery here. So for next time, because I'm gonna end the stream here, but here's what I'm gonna do to make things a little bit easier for myself. Is I'm going to disable the PB builder. I'm just gonna have one when we update. We're just going to update the builder and not the private browsing builder one. Oh boy, where is it? Update here. We're just going to comment this out for now. We're just going to do the one. I'm going to shut down. Oh, no. I'm also going to see if this crashes now. Hello? Come on. Close. Oh, continue. That's what's going wrong. Shut down. Okay, so we got called here again from the main thread to populate. This is on shutdown. That's really interesting. JS stack. I need to dump. Here we go. We build the list on notify. So quite soon before shutdown, we got our notifier. Dispatch. Shut down. Update. Say, if not this, if this starts shutting down, return, and then build list. Shutting down. I wonder, some of these things. if not this shutting down, because this may have become true in the meantime. Okay. That's interesting. So, continue. Continue. Oh boy, yeah, a lot of these must have stacked up. And then we crash. Okay. Do shut down. Our current thread is 1DADD341. The owning thread is 1DADD340. And the jump list backend owning thread one DAE89. What? Our owning thread is 1DAE891. That is not who we expect that to be. 1DAE891. Who is that? Who is that? That's the mystery, because current thread is 1DADD341. This is very interesting. I think we need to assert is thread assert on thread. We need to add like some assertions, not just that we're not on the main thread, but that we're on a particular thread. I think that's important. Like Moz assert something like thread. Is there something in here that's kind of like that? Is on current thread. M serial event target is on current thread. That might be kind of like it. Is on original thread. Yeah, this is what we want. Like M thread equals get current thread. Do we even have that? Because are we an event target? NSI event target? I don't think so. But we can write this ourselves. Assert that M thread equals PR get current thread. We can do that. So that's the other thing I'm going to do is investigate shutdown crashes by adding mthread equals Moz assert, mthread equals get current thread, basically everywhere, especially at shutdown. Not just that we're off of the main thread. I think that's important. Yeah, that's really interesting. Somehow, the thread that we're on, jump list 5. There's a jump list 6. Did we create... I think I know. I think I know. I think I know, everybody. I think I know. Okay. Guess what? Guess what? And I understand why it's non-deterministic. Oh, okay. It's worth it. It was worth the wait. It was worth the wait. So IO thread is a lazy idle thread. Oh, yeah, I could make this a cliffhanger, but then I risk forgetting. So I'm going to tell you now. So the IO thread is a lazy idle thread. A lazy idle thread is very interesting because if we look at the definition of a lazy idle thread, where's lazy idle thread.h? Is a basic event target, creates its thread lazily, destroys its thread after a period of inactivity. Which means that anything that it created oh boy, yeah, it gets destroyed. So basically we need to make it so that when the thread gets shut down, all the things it owns also gets shut down. Shutdown method is automatic shutdown. Shuts down the lazy idle thread waiting for any pending work to complete. Must be called from the owning event target. I think that's what's going wrong. Lazy idle thread. We're doing manual shutdown. Basically, the thread needs to know that it is shutting down and must clean up. Yeah. Yeah, that's what's going on. Yeah, okay, so let me explain. Yes, it is about timing. So the lazy idle thread, here's the story. The jump list builder is created on the main thread. I should write this down. The jump list builder. Okay. I know what's happening. The jump list builder is created on the main thread. That class creates a lazy idle thread, MIO thread, which is responsible for creating the jump list backend, for instantiating the jump list backend, aka the native jump list backend. But guess what? A lazy idle thread will shut itself down after a period of inactivity. That's part of its charm. That's part of how it works. That means that when we tell it to shut down the jump list backend, when the whole thing is, when it comes time to shutting everything down, we're asking a lazy idle thread to destroy the jump list backend which might not be the same thread that created it, thus hitting our assertion. That's the problem. And so what I think we need to do, what we might need to do, is to either, one, destroy the jump list backend anytime the lazy idle thread is shut down, or two, we need to hand the responsibility for creating the jump, for destroying, basically move the jump list backend destruction responsibility to the main thread. I like that less. I actually think we could get away with destroying the jump list backend every time the lazy idle thread is destroyed. That's presuming the lazy idle thread can know when it's destroyed. Man, it took us a while to get there, but I feel like we got there in the end. Lazy idle thread. So how does it work? Lazy idle thread shutdown. Await shutdown and idle. Task queue. Lazy idle thread shutdown. So we... No, not quite. Idle. Delayed dispatch. Register shutdown task. What does that mean? SI event target full. Register shut task. Register a task to be run on this event target when it begins shutting down. Shutdown task may run in any order. This function may be called from any thread. The event target may or may not continue accepting events during or after the shutdown task. Delayed dispatch. So not quite. How do lazy idle threads work? Lazy idle thread. Where's the period of inactivity? Implements the timeout is the thread pool. Thread pool. Set thread limit. Set idle timeout. I see. And when the thread is idle, idle thread timeout. It's like, how do we shut them down? Just shut down thread on exit. Shut down with timeout. Stop waiting to leak the thread, forcing on collision. Start counter and register, collect, decrement outstanding threads when threads finish. Then we spin. Oh, that's interesting. Spin the event loop until the threads are gone. MSI thread shutdown. And for ongoing shutdown, threads should be used to observe and interrupt async shutdown progress methods and consider. And leak thread. Wow. Okay, well, somehow I think we need to make sure that the idle thread knows to throw away the back end. That's what I think we need to do. So what I'm going to do next time is I'm going to be looking at anything that uses lazy idle thread to instantiate anything. Thread. Handle own. Dispatch, runnable, background process, load, queue. Lazy, assert running on lazy idle thread. Do we ever like instantiate anything new? That's on the parent process. This is running on the lazy thread. Private P, untrusted modules promise. Okay, well, maybe I need to talk to some of our platform folk who maybe know what to do here, who have maybe a better sense of what to do. But wow, that was intense, but I'm relatively confident now I understand that that's what's happening. Is the lazy idle thread is being told to shut down a thing and throw away something that it didn't actually construct. It wasn't responsible for constructing. Which makes a lot of sense. That makes a lot of sense. Okay. Well, thank you for watching episode 331 of The Joy of Coding. I know that was maybe a little torturous with, slow going and debugging, and we're not sure what's going on. We actually, I think we have a couple of layers of issues here. We've got this lazy idle thread business as part of it. The fact that the NS error failure is occurring, like we're not getting the URLs back, mainly because we're not properly beginning the list. I don't know what's going wrong there, but we are going to have to figure that out as well. That might actually require like a full OS restart. That could be, or like a shell restart to get into a better state. I'm not entirely certain. That's tricky because we're in that. That's what we're talking to, is we're talking to the Windows shell, and it's not even letting us begin the list. And that means I think that the Windows is in sort of a funky state, which is a bit bizarre. But I think we've got a handle on why we're shutdown crashing, and I just need to talk to some threading people to sort of figure out what our best approach should be. Thanks again for watching episode 331 of The Joy of Coding. Let me know what you thought. There's a rate this episode link at the bottom of the agenda. I'm also going to put the link into the chat. Rate this episode. And tell me what you thought. If you have questions, thoughts, maybe you have your own insight into what's going on here, you can send me a message in the Rate This Episode forum. I read everything that comes in. I love hearing from you. And I'm going to stop it there. Thanks again for watching. Have yourselves a great day. Hopefully we'll talk to you next week. Take care, everybody. Bye-bye.
The joy of coding.
See ya.